Hello and welcome all to this lecture 3 of section 3. This is video 8 section 3 lecture 8. Here we are going to study about private versus public IPv4 addresses. Public IPv4 addresses are the addresses that are routable through the public network, that is internet. So the packets of these addresses can go anywhere through the internet. For using IPv4 addresses, public IPv4 addresses, we have to buy them and then get it registered for its use. Once you buy that and register in your name, it is globally unique. Nobody else can get the same IPv4 public address. It is similar to the telephone numbers which are unique. Private IPv4 addresses are not routable through the public network. That is, they are not routable through the internet, but they can be routed only inside your private network or inside your organization's private network. These are all free and they are unique only within the private network. Every class of network has got few range of networks that can be used by any private organization for their private use. So class A, class B and class C. These are absolutely free and confined within the internal use for each organization. The same private ranges can be used by any other organization and will remain unique within their organization. So if there are millions of organizations, they can use this same class A, class B and class C private IPv4 addresses because they remain unique within your organization and the packets sent from them are not routable through the internet. So there is no conflict. For class A, we have got the 10 series as private address. For class B, 172.16.0.0 through 172.31.0.0. So this 8 bits and this 4 bits, 16 through 32, let us say, because one after that will be 32. So these are the 4 bits. So 8 plus 4, 12. So these 12 bits have been given for class B private IPv4 address range. For class C, we have got /16. So class A, this is /8, this is /12, but while doing the calculations we use at /16 only, and in class C while doing the calculations we use it as /24 because this X has got 256 different values. So this can be, let me show you in the next video, next screen. So 192.168.0.0 is one of the network, 192.168.1.0 is another network, 2.0, 3.0 all the way to 255.0. So there are 256 such free networks in class C. For class A, this is one single network or one single subnet. For class B, this is one single network or one single subnet. For class C, there are 256 different subnets for private use. So let us summarize about this in a tabular form. So class A, the whole of the 10 series. So the network address is 10.0.0.0 and the broadcast address is 10.255.255.255 because remember, second, third and fourth octets are for the hosts. So this is the broadcast address, all 255 is the broadcast address, and the first valid host will be one more than the network address and the last valid host would be one less than the broadcast. So first valid host is one more than network and last valid host is one less than broadcast, and this if you count they will be 16,777,214. We have already done this calculation in the previous video. Likewise for class B, the network address of the free IPv4 addresses in class B range is 172.16.0.0 and its broadcast address is 172.31.255.255, and this is the first valid host, this is the last valid host. So we get the first valid host by adding 1 to the network address and we get the last valid host by subtracting 1 from the broadcast address. And if you remember those calculations, these numbers, these valid host numbers would be 65,000 534 after subtracting one network address and one broadcast address. Remember the formula: number of hosts, valid hosts, is equal to 2 to the power host bits and then subtract 2 from it. Likewise, for class C, there are 256 different subnets and each subnet can have a total of 254 hosts inside this. So the first network address is 192.168.0.0 with a broadcast address of 192.168.0.255, and anything in between this are the valid hosts. Likewise, this is the second subnet, third subnet, fourth subnet. So 0, 1, 2, 3, 4, and then 255 is the 256th subnet because counting starts from 0. So 0 is number 1, 1 is the second subnet. So 255 is the 256th subnet, 254 is the 255th subnet. And there is something called supernetting or summarizing. If I combine them all together, this becomes a supernet. These are the subnets and this is the supernet. So supernetting concept we don't need in this particular series, but when you study your networking in the advanced part, that time you will have to do supernetting in order to save some memory from our routers. Okay, let us now discuss about them. So for class C, there are 256 different private subnets. For class A, only one. For class B, only one. And we know how to find these values. Now let us see what are the public addresses. So we have also seen in one of the video that for class A, the first octet range is 1 to 126. So from this range, if you get rid of number 10, why number 10? Because for class A, the whole of the 10 series is private. So if I get rid of this 10, so it becomes 1 through 9 and 11 through 126. Then these addresses are the public addresses. Second, third, fourth octets can be any values between 0 to 255. At present, we are interested only in the first octet value. Likewise, for class B, the first octet range is from 128 through 192. Now in this, we have seen that 172.16.0.0 through 172.31.0.0 is the private class B IPv4 address. Also, there is one more private class B IPv4 address which is called APIPA, and its range is 169.254.0.0. Now this is a protocol, APIPA is a protocol. This protocol comes into action when your DHCP server fails. So suppose there is a DHCP server in your private network and that is assigning IPv4 addresses automatically to your hosts. If that DHCP server fails or for some reason your host cannot reach the DHCP server, then what will happen? That network device will automatically assign IPv4 address from this particular range. So this is also a type of private IPv4 address. So from this range you get rid of the private range, this one and another is 172. So whatever comes, those are the public IPv4 addresses. For class C, 172.168.x.0. So everything over here. So 192.168.0.0 through 192.168.255.0. So 192.0.0, because 192 is the minimum value for class C in the first octet and 223 is the maximum, which we have already seen in the previous video. So 192.0.0.0 through 192.167.0.0, because 168 is private, and then again start from 169. So these two ranges are the public IPv4 addresses for class C. Generally in most of the questions exams you will be asked which type of address is this, especially about the 169. Generally people, as soon as they look at 169, they consider it to be a PIPA address, but no, a PIPA address is only the second octet 254. So we have to be very careful when looking at 169 series. Now let us have a lecture summary. So private versus public. Public we have to pay, private are free. Public globally unique, no duplicate exist. Private, they are unique only within your private network or your organization. Public, they are routable via internet. Private, they are routable only within your private network. They are not routable via the internet. For public, can be used only by a single buyer. If you buy, then it is registered in your name, or if an organization buys, it is registered under the organization's name and nobody else can use it. Private, same private address range can be used by as many private networks as possible or as many organizations as possible, because they remain unique only inside your private network and they are not routable via the internet. For private addresses in class A, class B and class C, these are the free ranges. Don't forget, in class B 169.255.0.254.0.0, that is a PIPA. That is why I have not written over here, but I have mentioned over here. So if you want, you can add over here, it's not necessary. So this is about the lecture summary, and let me see what else is there. Okay, after this we have, this completes section 3. In section 3 we had lecture 1, lecture 2, lecture 3. Okay, now let us have the summary of section 3, IPv4 classes. So here we studied that it is a hierarchical division based on classes, and these classes are class A, class B, class C, class D and class E, of which class E is reserved and class D is for multicast. So we cannot use them. We can only use class A, class B and class C IPv4 addresses, be it private or be it public. Public we have to buy. The first octet values of each class was for class A 1 through 126. This is what we used earlier. Okay, if you look at this particular case, while finding this one, we use that first octet value. For class B it is 128 through 191, and don't forget that 127 is reserved for loopback. We cannot use 0. 0 is also reserved. Now inside this we have got 169 for a PIPA. For class C 192 through 223, and don't forget that 192.168. whole series, 192.168 whole series is private. For class 3 it is 224 through 240, but this is for explicitly for multicasts. So default subnet mask and the corresponding default prefix lengths we have also seen. For class A, the subnet mask, the default subnet mask is 255.0.0.0, or it is same as /8, and there can be over 16 million hosts per subnet or per default subnet. For class B, the subnet mask is 255.255.0.0, same as /16, and these are over 65,000 hosts. Likewise, for class C, the subnet mask or the default subnet mask is 255.255.255.0 or /24, and per subnet we can have 254 hosts. Don't forget that class C has got 256 different private subnets, whereas class A and class B by default it is one single subnet for class A, one single subnet for class B. When we calculate valid number of hosts in IPv4 subnet, we subtract 2, because the first address is the network address and the last address is the broadcast address, and these two addresses cannot be assigned to a host. This is yet another rule for IPv4. In class A, B, C format, and default number of hosts. So for class A the format is network host host host, and we already found out this. For class B the format is network network host host, and we have already calculated this. For class C the format is network 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 host, and we have already done this calculation. So 8 bits for the network and 24 bits for the host. In class B 16 bits for the network and 16 bits for the hosts. Likewise in class C 24 bits for the network portion and 8 bits for the host portion. We have also seen the comparison of private and public IPv4 addresses. Private are free, public we have to buy. These are unique within your private organization. These are globally unique. These are not routable via internet. These are routable via internet. We have got some range of private addresses, and those private range of addresses can be used by millions of organizations because they remain unique within the private network. But over here once you buy, it is for you. These are the free range of private addresses, and anything excluded from here will become the public address. That should be it. I think this was a very long lecture. Make sure that you understand these concepts clearly. Thank you very much for watching this video. See you in the next video. Thank you and bye until then.